Hello. Um, I've already doodled stuff, but this is for my own, because I went through two solutions because I wanted to see if I could understand both solutions, for problem two, because I think this one's quite fun. And, yeah. Um, so we are trying to rotate a singly linked list. I didn't put singly here, but I'll write it now. Um, so I really like this question, even though it's a linked list question. And I don't really know why. Maybe it's just because I'm like, I am obviously not really that familiar with linked list. So I took some, um, from the time when the last assignment was due to now, I did some my own studying, and I read all about linked lists and hacks to them and tricks to them. So basically, I sought some extra help just on the basic foundations and concepts of a singly linked, of linked lists in general. So I think I have a better grasp of it than before in terms of foundation, and it's less intimidating to me now. But like, what kind of blew my mind was like, these nodes are, they're not connected in like in an array where it would take the same spot. They're just floating in the computer's memory somewhere as like little nodes. And all that actually talking about, we're not actually talking about like the nodes in a list. We're just talking about the pointers to them. I didn't actually know that. So, um, like all when we're saying node dot next, I'm like, oh, like whatever the node is next. No, we're not talking about that. Node dot next to me now means it's just the pointers. Like I don't know where I've been. It didn't hit me until now. I was just like, so all we're doing is just adjusting the pointers, which is like basically like mundane, but like it's like a laundry list of logic to do. It's not difficult. You just have to do it, right? Like, it does get difficult, and it definitely can be difficult, but it also, I didn't know how much it would help if you freaking just drew it out. So, by my own studying and some hacking and asking around, I finally feel less intimidated. And then this is like the second problem that, like, well, this one I had to actually draw out. To really see it, and once I see it, I'm like, it's so beautiful. So, but there's two methods. I'm gonna go with method one because, like, I understand both methods, and I will explain both. But just to make these videos like less 40 minutes long, 'cause I don't want to watch. I don't want anyone watching me talk for 40 minutes. That sounds like a nightmare. Also, my baby could wake up anytime, so I know I have to finish a video in a short time frame before her nap ends. So I don't get 40 minutes all the time to record. So so problem number two, let me just say the problem statement, and I don't think I spell singly right. I thought that looked a little weird. Sorry, English is not my first language, so my spelling and syntax, grammar is not very good. Um, you could probably tell by the way I talk, I sound like a peasant. Um, So, blah, 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 blah. So the problem number two asked us to rotate a linked list. Given a singly linked list, rotate the linked list counter clockwise by k nodes, where k is a given positive integer smaller than or equal to the length of the linked list. Good thing that was mentioned, because I was thinking of ways where we could. We would have to figure out the length of the list otherwise if we didn't know that, and that would be take a little more time. But yeah, so for example, if the given linked list is 10, oops, well, here I did one. So 1, 2, 3, 4, 5, and like and six, I guess. Oh no, that would remind. Okay, well, the example I wrote is from LeetCode. The example given and the question is different, but I'm just gonna read it. So if the given linked list is 10, 20, 30, 40, 50, and 60, and k is 4, the list should be modified 50, 60, 10, 20, 30, 40. So basically, like, in this example, I already have on screen because I already have it. K is 2. So what we want is basically moving it by two spaces. So we're going to, our end result should be, instead of 1, 2, 3, 4, 5, it would be 5, 4, 1, 2, 3, because we're moving these two places out and putting them in front. So that's what that means. I should probably I'm just gonna draw out the example that was given on the page. So 10, 20, 30, 40, 50. This is gonna be a long video. 60, because I have so many things I want to talk about and I don't want to forget it. And K is 4. That means that we have to move it 4 times. Yeah, 4 times. So this should be my, yeah, so, oh, this is, sorry, counterclockwise. Duh, okay. So, yeah, I'm glad sorry, this is clockwise. This is counterclockwise. So we're gonna move these 1, 2, 3, 4, 4 spaces, and then we're gonna move this here. So it becomes 50, 60, and then 10, 20, 30, and 40. Yeah. Sorry, this example that I have for method 2 for from the code is clockwise. It shouldn't matter. It doesn't really matter. But I guess I need to pick an example. So I should probably stick with, okay, well then that's fine. I'm just going to use the problem example and write it better, and I'm going to delete all this stuff here after I explain method 2. But I'm going to code out method 1 because I actually coded it out and tested it. Whereas method 2, like I saw the code and I'm like, I'm just trying to understand how this logic works because everyone said it was so clever, and I'm like, what makes it so clever? And I look, because it's not any faster. It's um a little more confusing. But when I understood it, I was like, that is clever. So, um, basically, there's two ways of doing it. There's the method 1. It doesn't matter where your data is, but method 1 is going to um, um, traversing the linked list until you hit the K element, and once you hit the K element, you're going to um, declare, or you're going to sever the. I mean, you're going to keep track of where the head is and have temporary variables storing the head. But after that's done, you're going to sever the K, the next of K. And then do another while loop for node.next until you find the end of the actual, like if it points to null, and then adjust the null pointer. So like 60, adjust it and point it back to head. And yeah, so it's very mundane, that one, but it's more understandable because it's just doing it. You know what I mean? Like linked list is just adjusting all the pointers, making sure you don't lose the head. If you lose the head, everything will be gone. So like just doing a laundry list of logic to get to it. And method 2 is what is shown here, and I really like it because you have to traverse through the entire array first, and then get to the end, and then get the get this number here, and point it to instead of pointing 5 to null, you have to point 5 to the head, so it sort of becomes like this, instead of like a mental imagery of like just going around and around and around like that. So we're making a circularly linked list, and that's really cool because just as long as like K is not whatever, you you could just go through and break off whatever So you have to answer these two questions, which is where K is and where K is pointing to. So all you have to do is I wish I wrote and read these question marks. I probably shouldn't have used red, but because now I don't remember what they were about. But essentially, like we could come in here and then we could break this connection 3 to 4. We could break the pointer from 3 to 4, and we wouldn't lose 4 because it's already a circular. So like 4 would be now the new head, um, and 3 would point to null. You know what I mean? So I was like, oh, that's so much. I mean, it's kind of the same thing. That's why it doesn't matter. But I just wanted to understand both. I feel like this way is safer. But I already coded the first one out, so um, yeah. And so like you just have to and that's all you really have to do. Like now this 3 is pointing to null, and um the 4 becomes the like no, the 5 becomes the head, which it is, and or points to the head, which it is. So I thought that was really like cool. It's still confusing. Because I think I'm missing something. Oh yeah, we have to get the length of the. Yeah, I'm not good at explaining. Oh my god, I have to get the length of the thing and then subtract it by 2 to get to 3. So I wrote it here. I just forgot because I was blocked by the recording screen thing. But yeah, like get the length and then subtract it by the K, and then we get to the stopping point, which is 3, and that's how we know we could break the connection at 3, because then we're moving by 2 places. So we're taking these 2 and putting them in front, and then 3 gets to null. So yeah, it's just all very like intuitive. Um, when you make it into a circularly linked list first. So okay, that's my rant. I'm gonna delete everything because I'm not that was kind of embarrassing of a rant for me. Sorry. I don't I don't know. I'm just excited to understand something linked listy, okay? They've always been so headachy, but it's like now I'm just like, yeah, okay. You know, um just kind of know at least where I sort of am. It's just all because the concept of like the pointer is just it has nothing to do with nodes. Like the nodes don't know anything about anything. They're just nodes. The pointers are the ones doing all the hard work. So we have to, yeah, just learn how to code up and manipulate and deal with pointers. So that's really because you look at the code and you're like, what is node dot next dot next dot like what? Anyways, yeah. Hello. Okay, I'm back. Sorry, my dog needed to let out some steam and just started barking, I guess, for no reason. What was I doing? I erased everything. So crap. Do do do. I don't remember what I was doing. So the problem number 2, syncly linked list. Okay, yeah, I remember now. Okay, so give me a second. My phone. Every time. Okay, so I'm gonna draw the mental, so I'm gonna do the traverse method and just doing it without this circular linked list method, um because that's what I already written out before, so I'm not one for rocking the boat. So I'm just drawing so that it will be easier to explain, because it really does help, because we're not talking about nodes here, we're talking about pointers, and pointers, I mean, human brain just don't work like that. We just don't remember a pointer or whatever. Like it just helps to draw it out, and it saves so much time. I don't draw things out. Maybe that's why they were so just ugh for me. Because I didn't draw it out. I didn't illustrate it before. I expected my brain to just follow where the pointers were going, and that's just not how my brain works, or anyone's brain really, unless you're like a super genius. 50, 60. And so this is our input, and our goal output would what's the example given again? Should be modified to. Okay, yeah. So it would be. Wait. Uh, it's gonna be a long video. So I'm sorry about that, guys. Output. I output would be 50, 60, 10, 20, 30. So we're just going to adjust some pointers today. That will rotate this list K. I'm just gonna draw a big old box. K, what was K? Rotate 2, no 4. Ha, I'm dumb. 4, okay. Counterclockwise by 4. Okay. Yeah. Okay. So my mental trick with linked lists is we need a head. Like we need so many pointers pointing the head so we don't lose it. Otherwise, we're so screwed and there's no going back. So we need 3 pointers, 3 things pointing at a head. We need an I had this last night. God dang it. So we need 2 pointers to start off at 10 and 10, the node itself does not know it's the head. Only the pointers pointing to it knows and tells because that's what pointers do. The nodes themselves don't know anything about themselves. So we're going to have a head pointer here, like this, and then we're going to let's write out define rotate. Okay. So we're going to have 2 pointers here. What's it called? The one that will traverse through, which we will call node, and the head node, which is pointing at the 10, which is the head node. So I don't know if that's going to get confusing later, but so like I don't know what to call it. All head equals self dot head. Yeah, I was like, can I just call it head? But I don't know, it's gonna get confusing. And then node is also pointing ahead. And the head pointer, the head pointer is pointing ahead, so everyone's pointing ahead. And then we're going to iterate, or not, we're gonna traverse. I can't say that word. It's not my first language. It's not my first language. Traverse. Yeah. Traverse. Through. So for I and we should also. I mean, we already mentioned. Never mind. This example already said that we don't have to worry about if k is like any integer other than positive and it's not larger than the list. And so yeah, that's all taken care of for us. So I have don't have any edge cases right now to worry about, I don't think. Sorry, I burped. Probably shouldn't do that on camera. So we are going to traverse up until k, and we're going to do k minus 1 because we're starting at 1. So like if it's 4, we have to go 3 to get to 4 in real life. Do you know what I mean? So 1, 2, 3, but it's actually 4. So we have to go k minus 1 because off by ones, they're annoying. So yeah, because we're starting at 1, and then we for each we just this all this code here right now is just saying move on to the next one. It's like if we're in an array we would just increment by 1. Well, this is what that is, but we're not incrementing by 1 because this is a linked list. So we just say node.next. And then when we get to this was it when we get to this 40 right here, yeah, 40. So when we get to 40 right here, that's where kind of like the action happens. So we need to start worrying about, okay, how do we get 40 safely broken off from 50? And how do we get 50 safely to the head? Because there's a new head at 50 and we can't break it until we can't break it unless because we'll risk losing 50 and 60 if we break it prematurely. So this one was hard right here, this part. So so we have to now declare 50 as the head, and we do that by saying self where dot head equals node dot next, because now we are at 40 and now we are looking towards 50 and we want to make 50 the thing next to 40 as the new head. So old head becomes 50, I think, and node dot next, and then and then so this part was confusing to me because I thought we were talking about nodes, but no, we're talking about pointers. So I wanna so this part, this line right here was node dot next equals null. And I was like, wait, what? Wait, why are we talking about 50? Why where you want to move 40, the pointer for 40 to null, right? Not 50. Why am I? But it's not the node that is being that what node.next means. It's the pointer. So that's all was the freaking confusion for me. Was just like I thought they were talking about nodes when they said node.next. So I feel pretty silly about that. And everyone knew about that. Why didn't I? I didn't think of it. I didn't. I mean, where have I been? This seems obvious now. But yeah, that's why I was like, wait, why are we pointing node.next at null? Anyways, so that was my rant. That took me half a day, really. This is like easy for people with this problem. I'm like, I don't see how this is easy for me. So yeah, like node.next is null, which makes sense because we want to, that's our goal. We want to point forward, we want to make 50, a head node so we get to not lose it, and so we get to store it in a temporary variable or something, and then we get to safely delete the 40 to 50 connection and then move 40 to a null, and then yeah, so now we are at node 50. We're going to declare oops, is null now right here. Now we're going to write node equals self dot head, which basically so now we are basically going to traverse. So node right now is at 50 and it's kind of the head, but now the more important thing is we need to finish iterating through, if my pen works, we need to finish iterating through the rest of the list. We don't necessarily know how much left it is, like in this example where there's only 60, so we're going to do a while loop. While node, so we're at 50 right now. I don't know why my pen's going crazy. And we're going to, we are not addressing 60, we are addressing the 50's pointers to 60. So while node dot next then so if there's more places to go through, we'll go through it. So that's all we're saying. Like just like up there, we're gonna go node equals next dot node, and then that will land us on 60. And then the pointer but the pointer at this is just so confusing. But the pointer at 50, so node dot next, the pointer at 50, this guy right here, wait, no, sorry, this, sorry, I forgot to draw this. So this was pointing at null before, but now this guy right here, which is node.next, is going to go here because it is now the old head. I named it old head. Yeah, old head. That's why I thought it was so confusing. I didn't know what to name it. Then this would be old head. So yeah, like so your the 50 would be the head, and then 60 would be old head, and they're all connected, and 40 points to null. So we've successfully, using this code, rotated the singly linked list. It was confusing because I just can't seem to always break the mental trap of, like node.next does that mean the node itself, it means the pointer. So because yes, this is all just pointers. So I can't break that mental trap. Just visually, to me, it looks like node is like the main performer here, the nodes themselves, but it's not. So yeah, and I don't know. I don't know if I feel like I don't know if I explained it enough, but yeah. How do I think so? Like, oh my god. Yeah, and then we just connect it to, yeah, okay. So I didn't know what was a better name for old head, but yeah, I'm going through thinking if I explained anything or anything. And the node is the thing that we use to transverse through. And yeah, it's not, it shouldn't be so hard in theory. It's just switching a pointers. It's just and yet at the same time it's so difficult. Yeah. So, but it doesn't matter if it's method one or now I'm thinking method two with the making it a circularly whatever syncly linked list would be easier because this was a lot of explaining. Now I'm starting to see the beauty of that one. Because the code itself is just it's yeah. But yeah, so they both perform in linear time, where n is the number of nodes in the linked list, and the code only has to go through the linked list once total for both. So yeah, like I think time complexity is linear, and then space. I don't know what the hell letters from. Is that an M? Um, what's my pen? And the space. I don't think I need any space for either method, right? I think like am I making besides the linked list pointer? No, so I think space wise it should be constant. So yeah, that's it, I guess. Okay, cool. That was hard to explain. This was difficult to explain. Did I remember the k minus one? I did. Okay. Ba, 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 ba. Yeah. Okay. Okay, that's it. And space is